When you go for a walk and look out over a landscape like this, the ground beneath your feet feels permanent. It feels like a single, massive block of solid stone. But if we could drop an elevator straight through the dirt and rock, all the way to the dead center of the planet, we would see a very different story. To understand what's down there, we have to go back 4.5 billion years. In its earliest days, the Earth was a violently hot, glowing ball of melted material floating in space. Because the whole planet was fluid and moving, it went through a massive sorting process where everything shifted based on how much it weighed. The heaviest elements, like iron, sank to the very center. Meanwhile, lighter rocks pushed toward the surface. Touching the cold vacuum of space, the outside chilled into a hard shell, trapping the original white-hot energy inside. The Earth we walk on today is a stack of distinct layers, with a massive amount of ancient heat still locked deep beneath our feet. Let's step into an imaginary elevator and plunge straight down to see how that trapped heat is shaping the world right now. Our first stop is the crust. This is the brittle outer layer of light rock. Under the oceans, it's surprisingly thin, only about 5 kilometers deep. But under the heavy weight of mountain ranges, that crust can be as much as 70 kilometers thick. As we drop past the crust and into the upper mantle, the temperature begins to spike. We enter a zone where the rock starts to change. It remains solid, but extreme heat makes it weak and pliable, creeping like warm wax. This softened, heated zone is where the magma comes from that eventually flows out of volcanoes on the surface. This means that just beneath our hard outer shell, the foundation of the planet is being constantly softened and moved by the heat from below. We descend even further, 2,900 kilometers down, to a place where the heat is so intense that rock and metal can no longer stay solid. This is the outer core. It is a wildly turbulent, swirling ocean of liquid iron and nickel that never stops moving. Finally, we reach the inner core, over 6,300 kilometers deep. This is the hottest point on the entire planet. Usually, heat this extreme would turn anything into a liquid or a gas. But there is a massive amount of weight from the rest of the planet pressing down on this spot. This crushing pressure wins against the heat. It squeezes the liquid metal so hard, it's forced into a solid, heavy ball. Even at the hottest point in the world, the sheer weight of the Earth creates a solid, heavy anchor at its center. Let's rocket back up the elevator, rushing through the mantle and the crust until we burst back out onto the surface. Looking at these mountains now, we can see they are more than they appear. The solid ground is actually a thin, fragile shell floating over a massive, churning heat engine. Huge events like mountains being pushed up, earthquakes, and volcanic eruptions aren't just random accidents. They are the outward signs of all that ancient internal heat, constantly trying to find a way to escape to the surface. The ground beneath our feet is the top layer of a giant moving system that has been active for billions of years.